Cast is now starting. All attendees are in listen-only mode.
Hey everybody, welcome back to Young Engineers of Today. You might be a little bit surprised to hear an entirely different voice from the beginning of the semester. I don't know how much Mr. Dubik mentioned it, but I'm going to be taking over from here on out. My name is Thomas DeToy, Mr. DeToy. You can call me Thomas or Mr. DeToy, either way. Some of you may be familiar with me from last semester. Some of you may not know me at all. In which case, hello, I'm me. Nice to meet you. You. Some of you, yes. Some of you are already familiar with me, um, unfortunately. But yeah, so I'm going to be taking over from here on out. Today is a little bit interesting. I apologize in advance. I'm going to be a little bit out of sorts. I just dealt with putting a pet through surgery, but everything's okay. They're out fine. It was just a bit of a whirlwind of emotions for the last 12 hours or so. But that's neither here nor there. We're going to design a phone case with special guest video from SpaceX. So it should be hopefully a little bit more of a laid-back class today, which is perfect. I think that'll work out pretty well before we really get into the swing of things again with designing the phone case and moving forward from there. So I'll spend a little bit of time, I think, reviewing what we went over. I only had a little bit of time to review the videos before I popped into here. So if I'm at any point on something that like you guys haven't gone over yet, feel free to let me know, and I'll have a better idea of where you guys are, and then we will look at the SpaceX launch and a couple of other things, and time permitting, maybe we'll make a little bit more progress on the phone case today. But yeah. So let's go ahead and get started with that, and then we will figure it out from there. So let's see here. Well, we'll watch it again because it's neato. Ah, you thought I forgot about that. So, all right, you guys were working on a phone case, last I heard, and it was going to be a phone case for some variety of iPhone. The base specs, no T, specifications for the phone case in this particular project had you making a case for an iPhone 7, but I also understand that there were measurements there for different iPhones, so yours might have been a little bit different as well. So let's see here. Started off predictably with creating a new design and working in millimeters, because I believe a lot of our projects work with millimeters and centimeters and stuff like that. It's not often when we work with something in Fusion 360 for this class, at least, that you guys will be working in inches, which is a little bit of a pain considering that's what we're all used to. But you know, you go into engineering or any science-based thing or anything like that, you guys are going to be primarily working in a lot of metric as well. So it's kind of good to get familiar with it now, especially because the rest of the world uses metric. So you'll, regardless of what what American units are, um, it's good to have a concept of the metric system. So when somebody goes, "Oh yeah, I'm 2 meters tall," or "I'm 3 meters tall," you can go, "That's not right." Um, they could be 2 meters, but they'll be pretty tall. But anyway, regardless, point is, it's good to have an understanding of the metric system, regardless of what the measurement system primarily used in the U.S. is. And you guys worked entirely on the XY plane and drew a nice box. It was very exciting, and fun was had by all in drawing this box. Here are the dimensions of the different iPhones, just in case you were working on a different one. Then you projected that box outwards. So you had a box instead of a rectangle. As if it wasn't confusing enough, now I'm just going to seamlessly transition to a different use of the word box. Then using the fillet command, you went ahead and rounded the edges on said box, and that gave it a design that was more in line with what iPhones work with. And then you rounded the fronts and backs of it, front and back of it. Again, more in line with a lot of cases and stuff like that for iPhones. Well, actually, it's more like an iPhone, and then we can create the case from it. But anyway, from there you created a form and then a box. And then the box you've created off of that same XY plane. Projected it outwards, and then fiddled with the sizes a little bit so that the box was around the phone model, and then edited that form so that it still was sort of in that box shape, but it was closer to something that had like more of your fingerprint on it. It was more of your own design. Then we finished it and went, forget that. We'll go back to the box for the phone. And then you were going to start another sketch from there, which that's more or less, I believe, where you guys left off. So that's where you were. Before we get any further in that, let's go over the SpaceX Falcon Heavy launch. Now, this was remarkable because it's certainly, if not the most powerful rocket ever built, it's the most powerful rocket built in the last 50 years. In fact, if we were to compare it to something like the Saturn V, as you can see, the Saturn V is pretty far up there on the scale. This is the Ares 5. Let's see here. I don't think this one actually includes the Falcon Heavy. Let's see here. This is a good one. Wait. So you can see the Falcon Heavy is pretty big. The Saturn V was a larger rocket, but at the same time, the Saturn V served a very different purpose from the Falcon Heavy. And the Falcon Heavy is meant to be something that is, expanded upon for the future. Obviously, it's meant to be the heavy variant of the Falcon 9, so named because it has 9 thrusters on the bottom. Falcon Heavy is sort of like a Falcon 9 with 2 more Falcon 9s strapped to the side of it. Yeah, the Falcon has more lift. That's true. It's a more efficient rocket than the Saturn 9 or Saturn 5. Excuse me. But yeah, so the Falcon Heavy is a much more powerful rocket than the Falcon 9. The Falcon 9 is also it's cheaper to launch. It's not by a whole lot, relatively speaking, insofar as how much you can get up into space is concerned. See, the Falcon 9 costs about $56 million to launch, 56.5. Oh, you built a Lego version of the Saturn V? That's pretty awesome. Saturn V was a monster. That was one of those things that I really enjoyed looking at as I grew up. But hydrogen versus kerosene, yeah. So the Falcon 9 costs about $56.5 million to launch. The Falcon Heavy, on the other hand, $77.1 million. But if you have if you're launching something basically into high Earth orbits, more than 6.4 tons, it's going to be $135 million. So about double the cost. of 6.4 tons or less, or an empty Falcon Heavy. What is just fuel? Well, they're the standard launch prices. So yeah, that's going to be modified based on what you're launching and stuff like that. But um, that is the standard price for launches as of 2013. Yeah, it did. However, the capabilities of each rocket are very, very different. So looking at $56.5 million, you can launch up to uh, 13,000 kilograms into low Earth orbit. Now, low Earth orbit is basically the lowest stable orbit. Not 100% correct, but it's the lowest stable standard orbit that is used in space flights. The name is pretty descriptive. I mean, low Earth orbit. It's a low orbit around Earth. Um, it is able to take about 5,000 kilograms to geosynchronous transfer orbit. Now, geosynchronous transfer orbit, it's an orbit essentially that is, geosynchronous orbit is one that means that if you were to look up something in the sky, if it's in geosynchronous orbit, um, it would constantly be over your head. It is more or less rotating at the same rate or it's orbiting the Earth at the same speed that it's rotating, in a sense. So it's able to take about 30,000 pounds, almost 30,000 pounds to low Earth orbit, and about 10,000 pounds, almost 11,000 pounds to geosynchronous transfer orbit. Now, the transfer orbit part of that is geosynchronous transfer orbit. It's a good orbit as well to be able to basically increase the size of the orbit so that you can leave the Earth's gravity well and move to another planetary body. So it's kind of like a Hohmann transfer for that was the kind of orbit that was used in many launches to the moon back in the day. So it essentially it involves increasing the size of the orbit until it encapsulates the moon as well, and then slowing down enough so that the orbit is just around the moon. Does the Falcon Heavy carry humans? Also, is this rocket reusable? So the Falcon Heavy, I do not believe is man-rated. You can correct me on that if I'm wrong. The Falcon 9 has been going through tests, and I believe it is. However, it's never taken humans. But I do not believe the Falcon Heavy has been man-rated yet, which is basically signed off by the government to be safe to take humans into orbit, or low Earth orbit, certainly. Also, is this rocket reusable? Yes. That's been the whole thing about the Falcon 9, is that the when the main thruster detaches from the assembly on the top, it actually lands itself back on a launch pad. These big old legs come out, and it slows itself down and rights it, and then lands on the launch pad, much like a 50 sci-fi rocket. So that's pretty cool. And the Falcon Heavy is built off of the same technology. Yeah, it could carry a payload of people, but it's not. Yeah. So yeah, 30,000 pounds to low Earth orbit and 10,000 pounds to geosynchronous transfer orbit on the Falcon 9. Now the Falcon Heavy, if we're looking at that 135 million number, because that's probably what we're going to be looking at for the performance values down here, because these are listing maximums. You were able to take, instead of 13,000 kilograms, you were able to take 53,000 kilograms into low Earth orbit, or 21,000 kilograms to geosynchronous transfer orbit, instead of a little bit under 5. So we're talking 5 times the amount of lift, which is very impressive. Very impressive for about double the cost. a little bit over double the cost. So in freedom units, I suppose, if you want to put it that way, low Earth orbit, the Falcon Heavy can take 116, almost 117,000 pounds into low Earth orbit, as opposed to 30,000. And it's able to take 46, almost 47,000 pounds instead of 10, almost 11,000 pounds into geosynchronous transfer orbits. Yeah, they would be in the payload bay in a pod. Yeah, that's the other thing is we don't really have a launch vehicle for humans that can currently fit in the Falcon 9 or the Falcon Heavy. It's under development, but it's not ready for prime time yet. And that would be the Dragon. The Dragon is pretty cool looking. Like that looks like the future of spaceflight right now. It's like an Apollo capsule, but in a sci-fi movie. It's pretty awesome. So the Falcon Heavy is pretty remarkable, and we're actually going to take a look at the most recent launch. And the reason why this one was pretty noteworthy is not only was it first takeoff of a Falcon Heavy, it also took a very important, Boring Company not flamethrowers. It also took a very important piece of payload, well, at least certainly to Elon Musk. It was Elon Musk's personal Tesla, and it is in space currently. So yeah, there's a car in space. Not just any car, but a car that was driving around on the ground not too long before it went into space. And I'm going to pull up a picture here, and I want you to basically just sort of contemplate on this for a second. Let's see here. So this is a picture of that Tesla in space. And it's got an empty, spacesuit sitting in it and everything like that. But this is the first time in history that the entire Earth has been reflected off of the side of a car. This is currently the only car in history that has had the entire Earth shine upon it. Well, one side of the Earth, but whatever. Do you think the car will function once the rocket lands? That's an interesting question. There are a lot of stresses involved in space flight, in takeoff and in landing. This is, of course, assuming that they ever want to bring it back, because they'll have to grab onto the car and put it into something that is able to withstand the heat of reentry and, bring it back in that way. I don't think they plan on bringing this car back, just because it's in space now. But they probably should. Anyway, point being, they left it up there for keeps, playing a song forever. Okay, so it's not planning on coming back. But let's say hypothetically they were able to bring it back. It's interesting to say, one small drive for Tesla, one long road trip for Tesla kind. Yep, this is going to be the longest road trip. Well, yeah, I mean, there's no real road, but it's... Oh, for the dummy. Okay. The dummy's up there forever. Gotcha. Yeah, I am. I've been a little busy over the last couple of days, and so I haven't been able to keep up much on this, unfortunately. You're all over the place, Cayman. You're confusing me, man. All right, but yeah. So, regardless, this is the fastest car in history. Yep. Yeah, that's true. It is currently the fastest moving car in existence. Who knows what the future holds? All right. Yeah, so two out of the three boosters were able to land back again, and so it's a for all intents and purposes for an initial launch, it's a very oh Falcon Heavy launch. All right, let's see here. All right, here we go, and I will provide this video as well. That way you guys can watch it at home much more easily. And we'll just spend some time watching this, because this is a pretty remarkable thing. Less than a minute left until launch. I'm going to go ahead and mute myself now while we go through this, and I'll unmute myself periodically to just sort of comment on things. Like I said, I muted myself, but I linked the video so that you can pull it up on your own. It's just so that there's no duplicate sound as well, because you guys will probably have a better chance of watching it on your own. There's going to be a lot of lag on mine, and it's not going to look very good. So as you can see, the rocket is rotating, and that's done in order to create basically a parabola. Instead of launching straight up, they rotate it and tilt it so that they can start accelerating sideways, which is what creates the orbit. Yeah, I hear you. And now you get to see the side boosters land on their own. And there's the car. Special useless 10 points to anybody who gets the reference that's shown on the dashboard screen, or not the navigation screen. And Dummy's name is Starman. That's awesome. It is, but it's in reference to something specifically. Main stage is getting ready to re-enter the atmosphere. Wait, those are the side boosters. Oh man. Okay. This part is a pretty amazing feat of engineering. And that, ladies and gentlemen, is how this rocket is reusable. Yeah, so all in all, I'd say that was a fairly successful launch. Now, as everything, as these launches become more refined and developed and things like that, this will become something that is more of a commonplace instance. It's one of those things where one of the things that happened with the moon landings and part of the reason why they stopped is because we got there faster than the Soviet Union. Um, there was a whole lot of fanfare and national pride over the fact that we were the first ones to the moon. Uh, over time, well, yeah, but I mean, it was that was part of the problem. What I'm saying is also part of the problem, but it was I think one of the biggest parts of the problem. But over time, um, it became a more commonplace thing. Uh, Enough so that by the time the final Apollo mission to the moon had landed on the moon, it was broadcast just the same as the first one. However, more people were tuned into the Super Bowl at the time than were watching the moon landing. We had gotten there and we had no idea what to do once we had gotten there. We didn't know what we could invest in. We didn't know what we could do next. Sure, we could do moon bases, um, but for what purpose? And now we have a better idea of what we can do out there as opposed to here inside, the Earth's atmosphere and on its gravity well and things like that. Um, on top of that, a lot of scientific progress sometimes is made for the sake of scientific progress. And as it becomes more commonplace, people find uses for it. It's sort of that shoulders of giants thing, where the internet. Well, let's say desktop computers may not have seemed that useful at first, but it was all of the incremental improvements and sort of the ecosystem that built around them that allowed them to become these powerhouses in our daily lives that they are today. Um, and that's the problem is we didn't know what to do with it now that we could get there. And the American public in general wasn't terribly interested in it. And so they didn't really know they had a hard time justifying continuing to go to the moon, finding the budget for it. And so a lot more started to become pressing in American public eyes um, in the subsequent decades. And it's not so much that NASA got its funding cut. Um, it's actually being paid more than it had then. However, it started to receive a smaller and smaller percentage of the budget. Oh, it did. Okay, awesome. Yeah, it was on the boat out in the ocean. Okay, excellent. Yeah, I don't know why this says that then. Um, we'll just cover over that and pretend that that never happened. Um, but yeah, so this, let me be the first to say that I am wrong a fair amount of times. It'll happen to you guys too. Just is part of being human. I'm wrong a lot. And I'll preemptively apologize for that if I end up sowing any confusion. I do my best to be right as often as I can. That's not me saying I'm wrong is not an excuse for me to just sort of be loose, fast and loose with the facts and backpedal whenever I'm corrected. It's more to say uh, it's okay when you guys are wrong too, because it'll happen at some point in the future as well. Now, I'm not saying that because there's anything wrong with you guys. It's just a natural part of being a human. Anyway, now that I'm going to get off of that soapbox and go back to the one that I was on originally, one of the things that I kind of hope is that this becomes a commonplace sight for the average person. Now, you guys are here because you're interested in this kind of stuff. You know, you think it's cool, or you at least think that some aspect of science and technology is really awesome and interesting. And so for you, the interest in this kind of stuff may never wane. And it's going to be people like you guys who are going to continually push the forefront in the envelope as far as this sort of technology is concerned. But my hope is that you guys will never lose interest in this kind of stuff. But the general public will go, it's cool that it happens. And, I rely on my everyday life, but, you know, I'm not watching the TV every time, um, the another set of rockets lands back on the landing pad. Because when it's hit that point, it's become a part of our um, our society. It means that we've made it so commonplace that something's going right. And maybe that's a little bit naive and a little bit, um, you know, enthusiastic of me. But at the same time, this is pretty amazing. This is the kind of stuff that's going to be in history books later on. Can you guys start giving diplomas? Trust me, if I had enough knowledge about any one thing to say, hey, I can give you a diploma on this stuff now, yeah, that'd be cool. But I don't. So unfortunately, no. You love space? Yeah, space is pretty cool. Space is terrifying and amazing all at the same time. Um, Space is inscrutable, but also just kind of there. And the more we learn about it, the more interesting I think it becomes. So, you know, if this is something that like really grabs a hold onto you, don't let go of it. And it may be that like you're really interested in space, but you're not flying a rocket or you're not designing the next booster or something like that. But you might be working on the telemetry software that allows people to communicate with satellites and stuff like that out in space. Um, you might be working on in chemistry to do a new fuel mixture for the liquid fuels that gets them out into space. You might be working on, you know, aerodynamics and stuff like that in order to figure out how to solve a lot of the complex sort of fluid dynamics and stuff like that that occur when a rocket is at maximum aerodynamic pressure. there are a bunch of different ways in which you guys can contribute to stuff like this. I mean, and it maybe space isn't your bag. Maybe you work on designing the next computer or something like that, the next integrated computer like a cell phone or something. But that's something that can be used for navigation systems for stuff like this as well. Um, so you never know. Well, hydrogen is very effective, but hydrogen is also super duper explosive, and that's part of the reason why they try and stay away from it. Explosive in a bad way. I mean, because it's very reactive, so it's explosive in a good way, but it's also incredibly volatile. So part of the thing that they try and deal with is um, a compromise between safety and reactivity. Especially they're going to start to stick people on the ends of these things. But yeah, so that happened. And even if you weren't witness to it in real time, you were alive when it happened, and you can tell people about it. And hopefully, for some of you at least, it'll spur you on to become people who spur the next historic event. Anyway. Now we're going to go back to designing phone cases. And you might be going, oh man, rockets to phone cases. Come on. Yeah, I'll grant you that. But if you're going to be designing the next really cool component to rockets, you're going to have to be familiar with computer-assisted design software. And the best way to get familiar with computer-assisted design software is to make something with it. So let's make our phone case. It's true. That's part of the reason why hydrogen is. So if you're using hydrogen, the water is fuel, which is very true, and that's actually part of what was used in like the certain stages of the Saturn V and stuff like that. That was actually it's historically been a fuel mixture, but that's part of the reason why we've been hesitant to do it because. What do you mean? I know we've used it's. I know we've used kerosene as well, but there have been oxygen and hydrogen mixtures before. Um, right. Again, because it's it's very volatile and it's difficult to compress. See, the thing is, hydrogen is a very good fuel because it's very easy to compress and it's very reactive. But oxygen is not. It's very difficult to compress it. Um, so it's uh it's hard to store enough oxygen to use for very large stages. I mean, there are a few reasons for it, but yeah. Okay. So it looks like we're going to be creating a new phone panel or a new phone case, and it's going to be a little bit more complex than the last one. Upload the provided data set. Okay, so there's going to be a data set. Staring into your soul emoji. Ah, come on. Okay, so let's check our handouts here and see if we've got the data set that we're looking for, phone case intermediate data set. All right, let me pull up my drive here and see if I've got it, because then I can provide it for you guys. Aha. All right, so I'm pretty much going to be able to get this data set for you, and then we can place it into the handouts, and then we can work from there. Oh, come along now. All right, one moment while I actually get the zip file prepared for you guys. I am grabbing the download for the data sets. And actually, it's not shareable via GoToWebinar. Unfortunately, it doesn't allow you to share zip files or anything like that. So I placed a link into the chat box. If you click on that, you should be able to you should be taken to the dataset zip file, and then you can just download it by clicking in the upper right hand corner here. But these data sets are going to be a bunch of points and stuff like that that you can use to recreate a 3D model. Denied. All right, let me change the permissions on this. There we go. All right, link sharing is updated, so you guys should be able to download it now. Awesome. All right, yeah, well, let's go ahead and get that downloaded. For the next time, you guys are going to be using the intermediate smartphone design. And we will build upon that, or the intermediate data set, excuse me, which is going to contain a little bit more of a complex phone design so that we can mess around with it and create a case for it, including like volume buttons and stuff. Anyway, with that in mind, I'm going to go ahead and do the poll question so we can leave it open for question and answer time, maybe have a little bit more discussion about the stuff, since it seemed like some of you guys were still pretty interested in discussing the Falcon launch. And then we'll go ahead and break and then meet up again on the next class. So let me go ahead and get started with the poll questions. And then after that, if you've got any questions about anything, I'm here. Otherwise, you're more than welcome to head out and have a wonderful weekend.